so in this video we're going to start doing the derivatives of trigonometry or trigonometric functions. So, you know, we have sine x. So if you have, let's just get right into it. If you have y equals sine x here, it's going to be, actually let me put it here, is going to be cos x. The derivative of sine x is cos x. So, you might wonder, what is the derivative of cos x? Well, you guessed it. Kinda. It's actually negative sine x. One thing to remember though, when you have sine x at face value, it is cos x. But we'll learn what to do when, you know, you have sine 2x or something. I'll get to that in a bit, but let's just try one. Say you have y equals cos 3x. Well, at that point, you're going to want to do the chain rule, where you have, well, let me just write it out, and you might actually just see what I'm talking about. Actually, this may be easier to do if I explain it to you like this. If you have y equals sine and then a function of any kind, then the derivative of that is going to be cos f of x, or whatever was in there, times the derivative of whatever is in that function. Similarly with this again, comes straight from the chain rule, where you do your internal function and then your external function. And there you go. So when we have something like, you know, y equals sine x squared, the derivative is going to be really just cos x squared times the derivative of what's in there, which is 2x. That's it. Similarly, if you have y equals sine squared x, then we can say that this is the same as sine x squared. And then we'll just use the chain rule, where we say u equals, u equals x squared and y equals sine u. So when you put that down, sine x. So that's what this is. So when you put this into the chain rule, then you're going to have dy over dx. The derivative will be which is, the derivative of this one, times cos x, which is the derivative of sine x, at which point u will become 2x squared cos x. Oh, sorry. This one's incorrect. Y equals oh no, I confused a lot of people. This is actually going to be y equals u squared, and u equals sine x. See, y equals, we're going to say u is the sine x, and y is equal to u squared. So the derivative of y is going to be 2u, as u squared becomes 2u. And then the derivative of sine x becomes cos x. Let's do another one. Let's do y is equal to cos of 1 plus x cubed. So let's start doing this one. Well, first, let's do the derivative of cos, which is going to be negative sine of 1 plus x cubed times the derivative of what's inside here, which will be 3x squared. And just simplify that. Negative 3x squared sine 1 plus x to the cube. And there you go. It's actually much easier than it looks. Say you have y equals e to the sine x plus cos x. Now let's do that. Remember our derivatives for exponential functions. You just rewrite the same thing. Sine x plus cos x times the derivative of the exponent, which is going to be sine x will become cos x, and we're adding cos x, but the derivative of cos x is negative sine x, so it's going to be, and there you go. It's just one step at a time. So before, I think I could add it to this video here. Obviously, when we're talking about trigonometry, you cannot forget about tan x. So the derivative of tan x is actually sec squared x. Wow. Yeah, but I should clarify from that if you have y equals tan with a function here, then similarly the derivative of y with respect to x is going to be plus 3x, then you know your dy over dx is going to be x squared plus 3x times the derivative in there, 2x plus 3. Yep, that is correct. What else do we have? We can do another one. Say you have y equals sine x plus tan x all to the power of 4. Well, now we can do our chain rule. Bring the 4 down. Write this again. Tan x times the derivative of what's inside. The derivative of sine x is cos x, and the derivative of derivative of sine x is cos x, and the derivative of tan x we know is sec squared x. Simple as that. Let's try one more. Y is equal to, say, x tan of 2x minus 1. So here we have clearly the product rule that we're going to try. So let's do dy over dx, and let's do the derivative of the first value, which is 1, times plus the x times the derivative of tan x over this entire function. You know what, I'm going to write it here, plus x times, so the derivative of tan x is sec squared times 2x minus 1 times the derivative of what's inside, which is going to be 2. So now you can rewrite this as tan 2x minus 1 plus 2x sec squared 2x minus 1. And there you go. That's how easy the trig ones are. If you want to try one on your own, you can do y is equal to 3 sine 5x tan 5x and find out dy over dx. And then just throw that into the comment section when you're confident. And yeah, that's all for this video. And I'll see you in the next one. Okay, so in this video we're going to be starting the vector section. So what is a vector? It is basically that, well, it's much more complicated than that. It's basically a mathematical quantity having both magnitude and direction. So a vector must have a magnitude and a direction. So in our case here, we have A and B, and we have a vector that says it's going from east. In this case, this is the magnitude, and that is the direction. So, we are going to use before we begin using magnitudes, we need to learn everything about them. So, let's go over some simple rules. So if this vector A to B here, and let's label it V, if that is V, then the same, let's say you have the same line going the exact opposite direction. This is negative V. So the magnitudes of these are the same, but their directions are opposite. So, what else can we learn about these? Let's see. Let's pretend these two lines are parallel. So we have A to B and C to D. So we have one of them is AB. We could actually say that AB and CD are parallel to each other, as well as, let's say that their magnitude, so the magnitude we would note as A like that under these absolute signs. Same magnitude. So if they are parallel and they have the same magnitude, then we can say that AB is equal to CD. So vectors are only equal to each other if and only if they're parallel and they have the same magnitude. Remember that. Now let's go into some actual, let's mess around with this. So let's say you have one vector, A, C, and you have another one, A, B, and let's say there's an angle between these two, and lowercase a dictates the magnitude. Lowercase a I'm using to say that is the vector. So what am I going to do here? Basically, in math, when you have two vectors, you could actually add them and say that, if you were to put this vector here and move it up here, that is your sum of these two vectors. So if this is 1, that's 2, this is 1 plus 2, and that brings us to the parallelogram law, stating that if you have this, then A and B then you have, let's pretend that there's this little B here. Or let's say there's this little A here. You could go actually either way. You could go from the top or the bottom. That is the same as that. That is the same as that. If you wanted to add these two vectors, you can go this way first, then up, or that way first, as that. So the angle of that is theta, and this is going to be 180 minus theta in the parallelogram. This angle is the same as that angle, and that's why we have that. So we can actually write out A plus B is equal to the vector AB plus B to D, which is from here to there, equal to a new vector A to D, which is that middle one there. So what else can we do? We can do vectors in the same direction. When you have two vectors, say they're both going just straight that way, say F1 and F2, then you have the sum of R. I'm just making these letters up as I go. The magnitude adds F1 plus F2 is equal to the magnitude of, and the direction stays the same. So maybe we can do an example here to kind of drill in the point. Let's say we have that's kind of long. A to D, and we have a B here. And let's say that's my A vector, and that's my B vector. And I'm going to give it an angle of 60 degrees. So let's say that the magnitude here is 3, and the magnitude here is 2. Now I want you to find out what is A plus B. So let's start doing that. So remember our parallelogram law. We're going to, if this is 60 degrees, then I basically want to find this one. Let's pretend that's a straight line. And that is A plus B, right? And I know the angle here is 120 degrees. And that's the same as B, which is there. And this is A, which is the same as that. So we know that A is 3 and B is 2. So when we use the parallelogram, we could basically use the cosine law. If you remember, we have, like if we were to redraw this, we basically have this side and that side, the angle of 120. So I know that this side is equal to 3 and that side is equal to 2. And I want to find that out, right? And my x is basically this. 3 squared plus 2 squared minus 2 times 3 times 2 times cos of 120. And remember, I'll do it step by step. 9 plus 4 minus 2 times 3 is 6. 2 times 3 is 6. 6 times 2 is 12. Cos of 120 is negative 1 over 2. You should be able to do that in your head. If you remember, I did a video on how to quickly find those special angles. So that is going to be 13 minus, what's that going to be? Negative, so positive. 6 x squared equals 19. So x is equal to root 19. So basically, so that is how we add vectors. Similarly, if you had, say, a and you wanted to find out, minus. So instead of adding, now we're subtracting. What we actually do is just take this up here and convert it into this a. Let me write it below here. Instead of doing this we are going to do the subtraction, but in simple terms, we just turn this b into a negative b, and now we just add like that, and that is now my a minus b. So that is very straightforward. I hope this is somewhat helpful in terms of an introduction to vectors. It's a very not complicated, but you just have to be very good at visualizing, things in the lines in the 3D space. So hopefully we can get more into it, but for now I'll leave it at that. And that's all for this video, and I'll see you in the next one. Okay, so in this video we're going to tackle vector properties. So we're going to go over a few rules and laws that will be used in calculus when we are dealing with vectors. More specifically, when we're dealing with vectors, algebraically, or when we want to simplify algebraic expressions, when we want to add or multiply, vectors. So let's write down some rules. So let's say you have vector A and you have a vector B. This is called commutative property of addition. Which basically states if you have a vector a and b, this can also be written as b plus a. Because remember, when you want to add this one to that one, it's the same as adding that one and this one. So, that is one. The second is the associative property of addition, which is, remember, from our polynomials. Actually, that was a while back. Let's say you have these three. Well, this is the same as saying that this is the associative property, implying that these two are associated. That's the same as these two being associated in this expression. We also have the distributive property of addition, and that is going to be if we have a k, which is a number, and that's being multiplied by this, the distributive property. If you remember when we covered multiplying binomials, k can multiply into this binomial to give us ka plus kb, where k is any real number. What else do we have? We have adding a zero vector, which is pretty straightforward. If you add a to a vector of 0, that is still a. What else do we have? We also have the associative law for scalars. And this basically says that if you have m multiplying times that, m and n are both real numbers. They're different numbers, but if you have it multiplying like that, the only vector here is a. That is the same as saying m times n times the vector, but it's also the same as saying mn times a. And then the final one, I guess, we have is the distributive law for scalars, which is m plus n times the vector a. This is going to be m a plus n a, the distributive law. So, I guess we could do an example here. We can do a few examples. Well, let's do 2 examples here. Let's do this one using these laws that we've learned so far. Let's say we have 3 times 2a is simplify this expression, and this is going to be very straightforward. So let's open up this first using the distributive property. So that's going to be 6a plus 3b plus 3c minus, I'm multiplying a minus 1 into here, minus 3b plus 2c. Now we can start moving them around using the commutative property. It's hard to say. Plus 3b, and then we have minus 3b plus 3c plus 2c. So, and I know it looks pretty straightforward just to start adding them, but I want to show you the distributive property for scalars, which is that. So now we have 5a plus 0b plus 5c, and 0b is basically the same as this. It's a zero vector, so we can get rid of that and we're left with 5a plus 5c, or it could also be 5a plus c, whichever one you want. We could do another example. Say you want to do x is equal to 3i minus 4j plus k. And let's say y is equal, I'll put them here, y is equal j minus 5k, and let's say we have z, which is equal to negative I minus j plus 4k. So let's do x plus y. So if we write out x plus y, it's going to be, 3i minus 4j plus k plus j minus 5k. So again, if you were to open this up, you would get 3i minus 4j plus k also do the same except x minus y. But when you open up the brackets, now these are negative. The sign flips for that one. And now you're left with let's see, 3i stays. We have negative 4j and a negative j, so that becomes negative 5, and then we have k and 5k. That becomes 6k. Now we can do one that's a bit more complex. Let's try x minus 2y plus 3z. So this is going to be a long one. So remember, our x is 3i minus 4j plus k minus 2 times y. And our y is j minus 5k. Where are you? Let's take this. What was it? Plus 3. Negative I minus j plus 4k. So let's open this up. So we have 3i minus 4j plus k minus 2j plus 10k. And what else? Negative 3i minus 3j plus 12k. So now that you have our I, we have 3i here, and then we have a negative 3i here, so the i's will cancel. That's good. We have negative 4j minus 2j minus 3j. So that in total will give me negative 9j plus 13k. Sorry, I jumped the gun there. Not 13, I missed this one too, so 23. So yeah, it's actually very straightforward to do these things. If you want to try one for yourself, you can try this one and put it in the comments, see what you get. minus 3 times 2a minus 4b plus 2c minus a minus 3b plus 3c. So that will conclude today's